Okay, this is an application of the integral test. So we should first make sure that we are dealing with a function that is always positive. Is this always positive?
Yes, sir. Yes. And it's always positive.
It is always positive. Is this... I feel like I'm missing something here. Let's say this is from n equals 1 to infinity.
Are we doing the integral test? Yes, sir.
Well, we're checking to see if we can use integral test. We need first that it's always positive, which we have. Is it always decreasing?
Yes.
It is always decreasing. Why? You could graph this if you'd like to see that, but the numerator is always growing faster than the denominator, so it's always decreasing. The denominator is always growing faster than the numerator, so it is decreasing. Is it continuous on this interval? It is always continuous. We're not worried about taking the square root of negative numbers or dividing by 0. Because we're starting at 1, not starting at 0. Okay, so what we're going to do first is define this as f of x. And now, f of x is equal to 1 over x squared times the square root of x. How do we simplify this? This is 1 over x to the 5 halves as, and I'll make a little side note, x squared times x to the 1 half, or the square root of x, is x to the 5 halves. So now what we're going to do is set up an integral. We're going to set up our integral from 1 to infinity of 1 over x to the 5 halves dx, which now we just have to evaluate this improper integral, which if you remember, we have to take a limit as k, or some dummy variable, goes towards infinity, starting at 1 going to k. In this case, we're referencing k, and we're just going to take that of the same argument, x to the negative 5 halves dx. And I like to write it like this so I can see right off the bat, I can do the anti-power rule. So this is the limit as k goes to infinity. What is the antiderivative of x to the negative 5 halves? We need to first add 1 to the exponent. Negative 3 halves is going to be our power. So we multiply by the reciprocal of negative 3 halves, so negative 2/3. X to the negative 3 halves, evaluated from 1 to k. So this is the limit as k goes to infinity of negative 2 over 3 times k to the 3 halves minus negative 2 over 3 times 1 to the 3 halves. I'm sorry, I could have written that inside like I did here. This is the limit as k goes to infinity. Thank you. Limit as k goes to infinity of negative 2 over 3 times k to the 3 halves plus 2 over 3. Now what happens to this term as k goes to infinity? It goes to 0. So really the limit is just 2/3. So what do we know about the improper integral? Does it converge?
Yes.
The improper interval converges. So what can we say about the series? Yes. So since the improper integral converges, so does the series.
Not necessarily at 2/3.
Not necessarily at 2/3. We just know that it is convergent. It's a very good distinction. And we can say that. So, since the integral is convergent, we know the series is also convergent. Nice way to sum it up, and we are done.